Yeah, thank you very much, Dr. Breyer, for this kind introduction. And I would like to speak with you over the next 10 minutes about all the EDOF technologies that we have available these days. So these are our financial disclosures. So in the past, we have basically had monofocal IOLs to achieve monovision and thus treat presbyopia, or we could opt for multifocal intraocular lenses. Monofocal IOLs, when they are targeted for monovision, obviously can provide full range of vision, but on the other hand, we have a loss of depth perception and intermediate visual acuity is not optimal. When we are talking about multifocal intraocular lenses, these lenses are certainly capable to create multiple focal planes, and that allows for a fuller range of vision. But on the other hand, we have an increased chance for visual disturbances and a reduced contrast sensitivity. And this gap is now to be filled by EDOF intraocular lenses. These EDOF intraocular lenses provide improved intermediate vision, they reduce visual disturbances, and they allow for better contrast sensitivity. These days, we have a variety of optical technologies that are available to create an extended depth of focus. We can achieve EDOF technology by diffractive technology, refractive technology, X-wave technology, and also the small aperture principle. We have looked at various EDOF intraocular lenses in the laboratory, and we have used an assessment using ray propagation imaging. And you can very nicely see that despite the different optical principle that these lenses are using, an elongated focus can be created with EDOF intraocular lenses. So let's now have a look at all the various technologies that is available in the field of EDOF. I would like to start with the Tecnis Symphony Iol, which was basically the first EDOF lens on the market. This lens is based on a diffractive achromatic technology that extends the focus and it compensates for chromatic aberration of the cornea. We are all aware that in terms of visual acuity results in the far and intermediate distance, very good results can be achieved. But we are also aware of the fact that this diffractive technology goes along with an increased rate of visual disturbances when compared to monofocal intraocular lenses, and we are also aware of the reduced mesopic contrast sensitivity when compared to monofocal intraocular lenses. When we look at the results that we obtained in our clinic, and we published that several years ago in a paper, we can very nicely see that there's quite a broad defocus curve achievable with that intraocular lens. And when it comes to the reading acuity that we assessed with the Salzburg reading desk, we indeed found excellent results in the intermediate distance and still functional vision that can be achieved in the near distance. We also assessed a mixed and match approach. In this paper, one of the eyes received the Symphony and the other one a bifocal intraocular lens, and we compared the results with a group of patients who have received a trifocal intraocular lens. The mix and match approach was a good option for patients with high demands in the near and intermediate distance, and the trifocal IOLs provided as a better option for patients with high demands at the near distance. So let's now switch gears and talk about the refractive technology. The LENTIS Comfort is also one of the first intraocular lenses in the field of the EDOF segment, and this lens is a refractive shape segmented bifocal IOL with a low near addition of just 1.5 diopters. The EDOF mechanism is based on a refractive bifocality and rotational asymmetry. We have assessed this segmental refractive MIOL several years ago on the optical bench, and we were able to show that excellent image quality is especially achieved in the far and intermediate distance, and at the same time, functional vision can still be achieved in the near distance. We also assessed this lens in a clinical study, and you can very nicely see that excellent results are achieved in the distance and in the intermediate distance, and at the same time, functional visual acuity results are also achieved in the near distance. Teleon now also has a new intraocular lens on the market, which is called the Aconex Vario, and that lens is also using this segmental refractive approach. It's a one-piece posterior chamber lens for an extended depth of focus and a high contrast sensitivity with an aspherical surface and a blue light filter. You can see that with this approach, a large range of vision can be achieved, and at the same time, the photic side effects are negligibly small. Another advantage, I think, is the material that is used in this lens. It's a hydrophobic, glistening-free material. In our laboratory, we have very often assessed the problem of glistenings, and in this article we have been able to show that glistenings do go along with an increase in stray light. Therefore, in my opinion, I do not want to see glistenings in any monofocal lenses, and I certainly don't want to see glistenings in lenses where patients pay a lot of extra money to get rid of spectacles. Let's now have a look at another IOL, which is the IC8. In this lens, the EDOF effect is created by the so-called pinhole effect. This IOL employs an opaque mask to create a small central aperture, and it's intended for just a monocular implantation in the non-dominant eye with a phakic fellow eye or an aspheric monofocal IOL in the fellow eye. So in terms of the visual disturbance profile, very good results have been published. Another advantage is that it can mask up to 1.5 diopters of astigmatism, but there are also some drawbacks. One drawback is, for example, the fact that quite a large incision is required. It's a 3.5 millimeter incision that you have to do, and there's also a reduced mesopic contrast sensitivity, although this is partly mitigated by the monocular implantation. We also assessed that lens in our research center, and we did once again a mix and match approach to achieve the best possible outcomes and to decrease the amount of photic phenomena. We implanted the IC8 in one eye, and in the other eye the MF20, which is a multifocal IOL with a near addition of 2.0 diopters. You can very nicely see that excellent visual acuity results were achieved in the far and intermediate distance, and at the same time also good visual acuity results were achieved in the near distance. We also assessed the amount of photic phenomena, and you can see that with this mix and match approach, the amount of photic phenomena would be acceptable for a majority of our patients. Before I end my talk, I also would like to quickly address the new segment of, let's call them monofocal plus intraocular lenses. In my talk, I have been mainly talking about EDOF intraocular lenses, which are there to achieve excellent visual acuity results in the far and intermediate distance. Monofocal plus lenses are not really comparable with EDOF lenses in that regard, that they achieve the same visual acuity results in the intermediate distance like the EDOF lenses. But if you look at the defocus curves, you can see that monofocal plus is able to provide about 1 line more of visual acuity in comparison to monofocal intraocular lenses. What is very interesting about this monofocal plus approach is that you are basically not losing any vision in the far distance, and that there are no photic phenomena, and therefore I'm quite sure that this segment will more or less rapidly push all the monofocal lenses away from the market, and I think that in the near future we will only see monofocal plus lenses. Teleon also has a new monofocal plus lens now on the market, which is called the Quantum, and I'm very interested to hear now in the following talks about this new intraocular lens that we will now be able to use in our clinical practice. So I really think that we are currently at the beginning at a very interesting phase in refractive surgery. Certainly an excellent time to be a cataract and refractive surgeon because we have so many options available. With the monofocal plus technology, I really think that we will not use in the near future traditional monofocal intraocular lenses anymore. And with all the great presbyopia correcting options that we have available, I'm quite sure that we will see many more patients getting these lenses in the near future. Thank you very much.
So thank you very much, Ramin. We are just continuing. So the next speaker is myself. And at the end, there will be time enough for questions. So we decided to do the presentations first, and at the end we can do the questions. So I was invited to talk about the quantum of solace, if it's worth having another lens like this. And this is the IOL I want to talk about today. And the question is it really a better standard IOL for all cataract patients? So let's go a little bit to the history of EDOF technology. I started 10 years ago, and it was really a pleasure to listen to this excellent overview, scientifically wise, from Ramin to guide us through EDOF technology. And 10 years ago, I had the big luck to implant one of the first Comfort IOLs, which was a segmental IOL with a near addition of plus 1.5. I didn't touch anything. So let's go ahead. Yes. And I really liked it because for me it was a real game changer. It had excellent far and intermediate vision without glasses, no clinical halo and glare, no reduction of contrast, sensitivity, and no more progressive glasses needed. So once you implanted those patients, they just needed reading glasses and not the progressive glasses they had to wear before when you did surgery to cataract patients or a refractive lens exchange. So this was surely a game changer. And during that time, I was traveling over the world a lot, also with Dan Reinstein, who would then develop the press beyond laser system. And I thought to myself, wow, this is very similar to what the MF15 can do. So I started to implant this MF15 as a blended vision approach. And the good thing was that those patients had the same advantages of the MF15 ametropic approach, but they could also read a book. And that's when I said at the beginning of this session, that's what I did to myself. So I don't need glasses anymore because I have an EDOF system with a target ametropy of minus 1.5 in my left eye. The disadvantage was that you needed still glasses for small print and 6 to 12 weeks for neuroadaptation. But be aware this is not possible, and don't try to do this with diffractive EDOF IOL. I tried it with a Symphony, and this was a bad idea. And those patients really have a lot of halo and glare. So the Comfort or other EDOF lenses we heard before that have a refractive design and not a diffractive design are better. This is the outcome. So the 105% of defocus capacity is even more than with trifocal IOLs. And as you can imagine, we have much better retreatment options because with a trifocal, you have trifoci. With a segmental and a blended vision, you can still, after 3 months, adjust to the patient's personal individual needs. So it looks like I wasn't the only one who thought this is a good idea. So how do we bring this to the patients? Basically like this. We show them the chart of halo and glare. We put a lens over the reading size and say, this is what you can achieve with a Comfort lens in blended vision. And the other thing, more halo and glare, is trifocal but small print reading. This is a translation. Then also already mentioned the next step in developing this kind of technology and new way to do eye surgery to our patients was Arconix Vario, because many people just like hydrophobic acrylic one-piece C-loop designs, so they don't have to change to hydrophobic plate designs like the Comfort. Nevertheless, I do like it very much. But here we can see very clearly why those refractive or progressive optics are better than a diffractive optics concerning halo and glare. It's a very simple picture to make this obvious. Now, this is the next step in innovation, and maybe a very good bridge product to get more and more cataract surgeons towards premium IOL surgery. Because the risk of implanting a lens like this is very, very low. You don't have any photopic phenomena, but you should also have only have advantages. So what is the new optical concept about? I asked, because if you look at the IOL, I didn't see anything. Not in the red reflex, not at the lens. I tried vision blue, I tried everything. I couldn't really see the optical and didn't understand it, so I asked Teleon, so what are you doing there? And they said, what we do with the quantum EDOF is to create a single elongated focal point to enhance the depth of focus, as others EDOF IOL do as well. But they apply a slope-constrained Q-type sphericity for a progressive power profile neutral to spherical aberration in the eye, not adding spherical aberration in contrast to other IOLs. And to those of you who love physical optics, I can only recommend this homepage from Damien Gattinel. This is a really excellent explanation how this IOL and how the constrained Q-type asphericity works. Let's have a look at the aberometry of the implanted lentis quantum. This is how the aberometry looks like in comparison the quantum up above to the Comfort MF15. And you can see there is even less induction of trefoil or coma, close to nothing with a quantum in comparison to the MF15. On the other hand, if you have less side effects, you should have less effect on the correction of vision. But we will see later on in the defocus curve. Then we compared this with the Polytech Isopure IOL, and with the Isopure IOL you can clearly see on the far right-hand side of the aberometry that they really do, they have a real crescendo of the spherical aberration from minus to positive spherical aberrations and clearly inducing spherical aberration, total higher order aberrations, which again in reverse means more photopic phenomena. Then let's compare this with alconvivity, and we've seen this before. There's a different concept with the elongating wavefront technology. And what we can see here is that in aberometry, the alconvivity is inducing astigmatism, spherical aberrations, coma, and a minimal trefoil. This is the quantum design. All of you know this design from the other IOLs up to now, and I'm going to report about the first implantation from Dr. Uy, and we implanted the first CE mark. So those data are mixed together or compared more or less, and we are looking to all the numbers you would like to know about this IOL. So if you look at the subjective refraction, there's a very high precision that we could reach. We didn't need a touch-up surgery in a single patient. Looking at the first results, uncorrected distance visual acuity, you also have a very high precision. If you compare it like we did to the aspherical IOL here with blue columns, there's clinically insignificant difference between those two. The same accounts for the corrected distance visual acuity. You have a very high precision and no difference between the aspherical design and the quantum. Looking at the immediate vision, and that's where we do expect the advantages of the quantum, we could see a clinical significant enhanced EDOF effect in the intermediate visual acuity, which maybe becomes more obvious in the defocus curve I'm going to show later on. And this also a very important part in premium IOL surgery is do we have photopic phenomena in photopic and mesopic conditions, and the quantum is very close to the aspheric design, so no, we don't have more photopic phenomena. The contrast sensitivity in both aspheric and quantum design is also the same. There's clinically no significant difference between those two. Here you can see the implantation. It was my first implantation. It's a left eye implanting with a left-hand fig, with a left-hand flex surgery in dock-on technique through 1.8 millimeters without OVD, just with irrigation, so I don't have removed the OVD. And as you can see, if you look at the red-right reflex, you really don't recognize any difference from an aspherical IOL. What I also do like with 4-point haptics, of course, they're very stable when you implant them as toric IOLs. So let's go on. So I do think that the quantum is not only a quantum of solace, but it really has an enhanced monofocal EDOF effect, and the quality of vision is also excellent. It's better than aspheric IOL in all regards, but not as highly potential as the MF15 or MF20, but that's not what we expected it to be. So we have an excellent precision, and we do have a great flexibility as well, because we can do a micro monovision or monovision blended approach, as with the Comfort IOL. We achieve a very high independence from glasses if we do a monovision approach, so with a high safety level and a high comfort level for the patients. And what I like in comparison to diffractive IOL, we have multiple retreatment options in late surgery with touch-up LASIK or add-on IOL if you want to improve and the patient's vision and meet his personal needs. So I want to thank very much, on the other hand, Teleon, who guided me through those 10 years, and they were always open for discussion. They never forced me to tell anything. They always gave me all the freedom with their products, and were very generous in spreading our ideas. So thank you very much for your attention. So now I'm looking, and we are all looking forward to hear from my friend Sunil Shah about the visual performance and patient satisfaction after implantation of a refractive segmental optic EDOF IOL versus mono-EDOF and enhanced monofocal IOLs. Sunil.
Thank you. So I'm actually going to talk a little bit slightly differently, just about ideas on how you can utilize EDOF lenses to give you the best possible results. So as you know, within the Acunax family, there are monofocals, there are multifocals, and we're talking about the group in between, the EDOF lens. And really it's to see whether we can give you some ideas when you should perhaps use these. So with EDOF technology, if you follow the color scheme through this, you'll see that the more purple we have, the better the vision in that sort of area. So with an EDOF lens, we're expecting excellent distance, but we're also expecting sort of good vision at 50 to 200 centimeters. So we're talking about computing distance. Obviously, most people don't read at 50 centimeters. But as you'll see, we can get a lot more out of this just by a few tweaks. So you've seen this picture from Ramin before, that unlike the Vividity or the iHance lenses, which are sort of more monofocal plus, then the Acunax Vario is actually more a full EDOF lens with a varifocal effect. So you actually would expect to get more out of this than the other two lenses. So we are going to talk about a lot of defocus curves, just to give you an example. So those of you who aren't familiar with defocus curves, what I'd suggest you look at is the peak of the curve. So when we're looking at zero defocus, that means we're looking at the distance. So you want to, at zero defocus, you want a logMAR of 0. So that's good vision. The second point is I've put a line at 0.4, which is one line better than 2040, but it's just as a reference line. So you could consider that good near vision. Different people will use different measures, but it's just a marker. But then the big one, which people don't talk about, is the area under the curve. Detlev has talked about this quite a lot in the past, that the area under the curve is your total range of vision. And if you compare this to a lot of different lenses, just the breadth of, the amount of area is very large. So in this example, this is what you would typically do. Both eyes aim for emmetropia, and you will get good distance vision, and you'll get good computing vision, and it starts to drop off once you get to the reading distances. So what can you do about this? You may not want to use a multifocal lens. The patient may have a bit of dry eye, so you're worried about using multifocal lenses. You don't want dysphotopsias. So there are very simple things you can do. So put one eye at -0.5. So, so here we will have one eye for distance with logmar of 0. Obviously, the -0.5 is slightly worse, but it's not much worse, and people won't really notice this. But what you do is you manage to get probably another 7 to 10 centimeters in your near vision. So it just pushes the near vision a little bit more. You can keep going with this. So you can go to -1. So of course you retain, so one eye is emmetropia, the other eye is -1. So you retain excellent distance vision at at the 0 defocus. But what you're finding now is you're getting good near vision even when you're getting out to sort of something like 30 centimeters. Depending on the patient, another good solution, don't do it very often, but you know, you find a non-driver and you put one eye at -0.5, the other eye at -0.75, and you have a distance acuity of 0.1. So still excellent distance vision. Maybe if they did drive, you pop on some driving glasses, but probably they don't need it. But actually your near vision is pretty good. And remember, all the way through, you've got seamless transition of vision. So you will cover everything in between your distance and your near. It's not like a bimodal multifocal where you'll have two peaks and very little in between. So there are patients who want just near vision. So if you give them, if you put them at -1.5, the effective add with this lens is about 1.5. So you give them a range of 1.5 to 3. So yes, the near vision, the distance vision is at the 20/40 range, but that's perfectly adequate for day-to-day living. Again, driving glasses, but they will be completely free of the sort of need for near vision. And you've already heard about a Düsseldorf formula, which Detlev has spearheaded, and I lost track of how many thousand patients you've done with this technique. I think very many thousand by now. 5,000, okay. So you can't do 5,000 eyes without this working really well. The idea here is you have one eye for emmetropia, and the emmetropic eye has a sort of goes out to 1.5 diopters effectively of near vision. And then the second eye, you target -1.5, and they go, and that eye runs from -1.5 to 3. So without losing anything, because if you look at the defocus curves, I mean, these aren't as summated, they've not been added together, but you can understand that effectively what you've done is you've increased the area under the curve without dropping the peak at all. So it's a very effective technique. You may want to try the patient for monovision, but Detlev, I don't think, has stopped bothering. He just puts this in as, and patients don't seem to notice the difference between the two. I mean, you obviously warn them, but they get such good vision across the range that it's not necessary. So just a quick run through on some of the ways of using lenses. I mean, why would you use a Accunex Vario? I mean, obviously it's an excellent quality lens. There's no dysphotopsia. So you don't need to worry about that. You've heard there's no glistenings. So if you're not a refractive surgeon, if you're not somebody who is comfortable using multifocal lenses, you can actually achieve the same sort of result with these lenses without having to worry about the patients. These lenses will be very tolerant. You won't have to worry about a lot of laser touch-ups or anything because you have a range of vision. Rather than treating it as a monofocal plus, I mean, it is an EDOF lens, but it is a significantly better lens than your monofocal. But you can use it in just a similar way to your monofocal and not worry about it. There are no problems with using the lens. And of course, the cost is significantly better than a full multifocal. Thank you.